Okay, so let's solve some equations that have fractions in them. On this problem right here, we're going to determine whether each of the following is a solution of x minus 3/10 equals 1/2. In order to do that, you have to put x minus 1, in this case, that line is a little bit thick, into where we see x in the problem. So I would write 1 minus 3/10 equals, I'm going to put a question mark above that, 1/2. So I'm going to test this out. 1 minus 3/10. I can grab my calculator, I could type it in just like I see it, 1 minus 3/10. But to do this by hand, let me show you, I need something with a common denominator of 10, so I'm going to turn that 1 into 10 over 10. 10 over 10 is the same as 1. 10 minus 3/10, does that equal 1/2? So 10 over 10 minus 3 over 10 is 7 over 10. Does 7 over 10 equal 1/2? Well, one way to check is you can cross multiply and see if those numbers are equal to each other. 1 times 10 is 10, 7 times 2 is 14. Those are not equal to each other, so you would say no, not a solution of that. Okay, on the next one, we're going to put 4/5 in where we see x. So 4/5 minus 3/10, does that equal 1/2? I don't know. I'm going to try to find a common denominator here. So a common denominator between 5 and 10 is 10. I don't need to change the 3/10, but 4/5 has now turned into 8/10. 8/10 minus 3/10 is 5/10. Does that equal 1/2? Well, you could do this one of two ways. You could cross multiply and see whenever you cross multiply, 5 times 2 is 10, 1 times 10 is 10. Those are equal. They're not equal, they're equal to each other. So that is true. Or you could have reduced 5/10 and seen that it was equal to 1/2. So in this case, 4/5 is a solution because 5/10 does equal 1/2. For the sake of being thorough, we're going to go ahead and try negative 4/5. So I'm going to put negative 4/5 minus 3/10 equals 1/2. Now, think about this for just a second. You have a negative number minus a number. Aren't you going to get more negative? So won't you have some negative number is equal to some positive number? So use your number sense here. Is it ever possible that a negative number is equal to a positive number? No, it is never possible. I don't even have to do the math. I know that there is no way that there is a negative number that's equal to a positive number. So I can stop right there. Notice I didn't do any math. I knew the answer, so that's okay. But you need to be able to at least show something like this on your paper. So don't just write the word no. Show that it's not possible that a negative number equals a positive number. Show your work. Okay, so to solve for y in this problem, I would need to look at what's happening to y. We're adding 9/16 to it. So to undo adding 9/16, you have to subtract 9/16 from both sides. So what happens whenever we subtract over here? They cancel each other out. So I get that y is equal to, what is 5 minus 9? It's negative 4. Your denominator doesn't change. This answer right here is not reduced, so you need to reduce it in order to get full credit. So y is equal to negative 1/4. And you would write it like this. Okay? Okay, for this problem right here, let's take a look at what's happening to our variable. We're subtracting 5/9 from it. So in order to undo that, you have to add 5/9 to both sides. So I get that a is equal to, this right here cancels, a negative 8 plus 5 is a negative 3. Denominator doesn't change. I need to reduce that. So a is equal to negative 1/3. And remember, you can always check your work. Take these answers, plug them back in, see if it gives you a good solid solution here. So you would do negative 1/3 minus 5/9. Does that equal negative 8/9? I'm going to turn this back into something with a denominator of 9. So I've got negative 3/9 minus 5/9. Does that equal negative 8/9? Negative 3 minus 5 is negative 8. And negative 8/9 does equal negative 8/9, so I do know that this is a good answer. Okay, for this problem right here, look and see what's happening to your variable. We've got 10q. What that means is 10 times q. How do you undo multiplication? You undo multiplication with division. So I'd have to divide both sides by 10. So I've got q is equal to 44/10. Well, those are both even numbers, so I know that they can be reduced. So I'm going to reduce both of them by a factor of 2. So 44 divided by 2 is 22. 10 divided by 2 is 5. So I've got that q is equal to 22/5. And you can leave your answer just like that. That's an improper fraction that has been reduced, so it's perfect. Okay, for this problem right here, I ask myself what's happening to the variable. It is being divided by 7. How do you undo division? Well, you undo division with multiplication. So I would multiply both sides by 7. On the left, those 7's cancel. So I get x is equal to negative 9 times 7 is negative 63. Okay, on this one, we look and ask ourselves what's happening to the variable. P divided by negative 8 is negative 40. So it's being divided by negative 8. So you want to multiply to undo that process by negative 8. So on the left, those negative 8's cancel each other. You're left with P is equal to, what is negative 40 times negative 8? It's going to be a positive 320. Okay, for this problem right here, you don't ever want your final answer to have a negative sign in front of the variable. So there's one of two things that you could do. I typically divide, but that doesn't mean you have to do that. You can multiply by what number wouldn't change the number in front of the y? Well, it's going to be a 1. So if you consider that to be a negative 1y, I typically will do this, divide by negative 1. And what that does on the left side, all it does is change that negative y into a positive y. And on the right side, it changes the sign of that number as well. 15 divided by negative 1 is negative 15. You could have multiplied by negative 1 on both sides. You would still get the same result. Okay, for this problem right here, a couple of things you could do. You could see this as multiplication, which is 3/4 times x, in which case you undo multiplication with division. If you divide by a fraction, though, that is the same as multiplying by its reciprocal. So I think the quick and easy way to do this problem is to simply multiply by the reciprocal on both sides. So multiply by 4/3. Remember that 24 is the same thing as 24/1. So on the left side, those 4's cancel each other, the 3's cancel each other, you're left with just plain old x on the left. On the right, the 3 will go into 3 once, the 3 will go into 24 8 times. 8 times 4 is 32. So that's our final answer here. Okay, just like that last one, I'm going to multiply by the reciprocal again. The reciprocal of negative 3/8 is actually negative 8/3. So I'm going to multiply both sides by that, negative 8/3. What you do to one side, you have to do the same thing to the other side. So on the left side, the negatives cancel each other, the 8's cancel each other, The 3's cancel each other. I'm just left with plain old W on the left. On the right, the 3 will go into the 72, 24 times? And so I'm left with 24 times negative 8. And 24 times negative 8 is negative 192. So W is equal to negative 192. On this problem, we're going to translate first, and then we're going to solve it. So it says divided by. Remember, we're going to use a fraction bar whenever we see that. So it says n divided by 6 is means equals negative 24. Now what's happening to our variable? It's being divided by 6. So you undo that by multiplying by 6. So on the left, those 6's cancel. And on the right, you have negative 24 times 6, which is negative 144. That's our final answer. Okay, on this one, they're using the fancy word for divide. They're using the word quotient. So how you write this is the quotient of Q and negative 5. Q has to go on top because that's the first thing you read. Negative 5 goes on bottom. Is means equals 70. So I would multiply both sides by that denominator. Negative 5, multiply by negative 5. The negative 5's cancel. Q is equal to negative times a positive is a negative. 5 times 7 is 35. Put my 0 on the end, so negative 350 is my final answer here. All right, we're going to translate this one too. 2/3 of F. 2/3 of F. 2/3 is written like that. Of means multiply, so I can just put that F right there next to it. Is means equals 18. And just like we did earlier, I'm going to multiply by the reciprocal of that fraction. Because then the 3's will cancel, the 2's will cancel, but remember what you do to one side, you have to do the same thing to the other side. And remember that 18 is over 1. So I can reduce the 2 and the 18, and I've got that F is equal to 27. Okay, for this problem, they're using the fancy word for divide. They're using quotient. So we would write this as M. The quotient of M and 5/6 is written like this. M divided by 5/6 is means equals. Now what's happening to our variable? It's being divided by 5/6. So what you can do is you can multiply by 5/6. So multiply by 5/6 on both sides. So that cancels that. M is equal to, now I can reduce the 3 and the 6. Can't reduce the 5 and the 4. So now I just multiply straight across. 1 times 5 is 5. 4 times 2 is 8. M is equal to 5/8. For this problem, let's translate it. The sum is the fancy word for add, of 3/8 and x, so 3/8 plus x is 3 1/2. So that's what that is in algebraic form. So you ask yourself what's happening to the variable. It's adding 3/8. So I'm going to subtract 3/8 from both sides. And that goes away. I'm left with x on the left-hand side. Now, I need a common denominator over here. So off to the side, I'm going to do 3 1/2, which can be written as 3 4/8 minus 3/8. And so 4 minus 3 is 1. 3 minus nothing is 3, so I get an answer of 3 1/8. Don't forget, check these problems on your calculator. It's okay to use your calculator to check your work.